Every Python developer hits the same wall on day 3. I want to show it to you now. You are working on Project A, which needs Library X at version 1.0. Then, a week later, you start Project B, and it needs Library X at version 2.0. You install it, and suddenly Project A breaks. You've just experienced dependency hell, a silent killer of software projects that wastes countless hours. I remember spending 3 days trying to debug a cryptic error, only to find out it was because I updated a seemingly unrelated package for a different project. It was infuriating. You are going to run into this, and I want to equip you with the tools to avoid it entirely. Today, our mission is to master your Python setup, transforming it from a source of frustration into a productivity powerhouse. We are going to cover 4 critical areas: how to install and intelligently manage multiple Python versions, how to isolate your project dependencies using virtual environments, how to supercharge your coding with professional IDEs, and finally, how to execute your Python code effectively, whether it is a script or an interactive session. When I first started, I thought install Python meant downloading one thing from python.org and being done. That works for simple cases, but think of Python itself as a tool, like a wrench. You wouldn't use a single wrench for every car repair, right? You need a toolbox with specialized tools, different sizes for different bolts. The official installer gives you one wrench, a system-wide Python installation, typically Python 3.x. This is fine for your first Hello World program, but for real-world development, you need a full toolbox. This is where tools like pyenv or conda come in. They let you manage multiple Python versions on the same machine, switching between them seamlessly. Imagine pyenv as a manager for your Python tool collection. You can tell it, hey, I need Python 3.9.10 for this project and Python 3.11.2 for that one. It handles the installation and makes sure the correct version is active when you need it. You can visualize it as a central dispatcher, pointing your Python command to the specific interpreter you've chosen for your current task. For instance, after installing pyenv, you might run pyenv install 3.9.10 to get that specific version. Then, to use it globally, you type pyenv global 3.9.10. Now, when you type python -- version, you will see Python 3.9.10, not your system's default. Conda offers similar capabilities, but it is especially popular in data science because it can manage non-Python dependencies like C libraries too. The common mistake I see: people install Python system-wide, then try to install another version, leading to path conflicts and broken installations. Or they install a package globally, then wonder why their system tools stop working. Always use a version manager like pyenv or conda. It is a small investment that saves you massive headaches down the line. Now that you understand how to manage your Python interpreters, isolating your project dependencies is going to make perfect sense. Think of a virtual environment as a clean, isolated workspace for each of your projects. When you start a new project, you get a fresh desk, a new set of tools, and no leftover clutter from your previous work. Python has a built-in module called venv for this. It creates a directory containing a copy of the Python interpreter and its own site packages directory. This means any libraries you install, like requests or NumPy, go into that specific environment, completely separate from your global Python installation or other projects. Let me show you how simple this is. First, you create the environment. I will call it my project env. You run python 3-mv env my project env. This creates a new directory. Then, you activate it. On Linux or Mac OS, you use source my project env/bin/activate. On Windows, it is my project env /scripts/activate. You will see your terminal prompt change, usually showing the environment name in parentheses. This tells you it is active. Now, if you type pip install requests, that requests library is installed only into my project env. If you then run pip freeze, you will see requests equals 2.31.0 or whatever the latest version is, listed as an installed package. When you are done, type deactivate, and your terminal returns to its normal state. The environment is still there, ready for you to reactivate later. This isolation is crucial for reproducibility, especially when deploying your code to production. The biggest mistake here is forgetting to activate your environment. You install a package, it goes into your global Python, and then your project still cannot find it. Or, you switch projects, forget to deactivate, and accidentally install a dependency for Project B into Project A's environment. Always check your terminal prompt to confirm your environment is active. Here's where it gets interesting. You can write Python code in any text editor, even Notepad, but that is like trying to build a house with a butter knife. An integrated development environment, or IDE, is your full workshop. Think of it as having all your power tools, blueprints, and safety gear in one place. The replace, on the other hand, is your quick scratch pad. For serious development, VS Code with its Python extension, or PyCharm, are industry standards. They offer features like IntelliSense for code completion, integrated debuggers that let you step through your code line by line, and linters that catch errors before you even run your program. These tools dramatically boost your productivity. The replace, which stands for read eval print loop, is what you get when you type Python into your terminal without a file name. It is an interactive environment. You type 1 + 1, hit enter, and it immediately prints 2. You can import modules, test small functions, or explore an API. For example, import math, then math.sqrt parenthesis 16 parenthesis will instantly show you 4.0. It is perfect for quick experiments or debugging a specific line of code. You can even use enhanced REPLs like IPython or Jupyter Notebooks for richer interactive experiences. But you would never write an entire application in the replace. That is what your IDE is for. The common mistake here is underutilizing your IDE. Many beginners treat VS Code like a glorified notepad. You are missing out on automatic code formatting, intelligent refactoring, and breakpoint debugging that can save you hours. Take the time to learn your IDE's features. It is an investment that pays dividends. Finally, let us talk about running your code. A Python script is like a recipe, a set of instructions saved in a .py file. The replace is like tasting a single ingredient. You execute a script by telling the Python interpreter to run that specific file, for example, Python myscript.py. The interpreter reads the file from top to bottom and executes each line. On Unix-like systems, you can make a script directly executable using a Shebang line. This is the part most tutorials skip. The very first line of your script can be #bang/usr/bin/env python3. This tells the operating system to use the env program to find the Python 3 interpreter in your system's path and execute the script with it. Let us create a simple hello.py script. It contains just 2 lines, the shebang and a print statement. The first line is #bang/usr/bin/env python3. The second line is print parenthesis quote hello world quote parenthesis. To run this directly, you first need to make it executable. You do this with chmod +x hello.py. This command changes the file permissions. Then, you can execute it directly from your current directory by typing /hello.py. When you run this, you get exactly this on screen. Hello world. A common mistake is forgetting the chmod +x step, which results in a permission denied error. Another is having the shebang point to a non-existent or incorrect Python interpreter, leading to command not found or unexpected behavior. Always verify your shebang path and file permissions. You now understand how to manage multiple Python versions with tools like pyenv, how to create isolated virtual environments for your projects using venv, and how to leverage the power of IDEs like VS Code for efficient development, alongside the interactive replace for quick tests. These are the foundational skills for any serious Python work. Mastering your development environment is not just about installing software. It is about setting yourself up for success and avoiding the frustrating pitfalls that trip up so many developers. Next time, we get our hands dirty with the actual building blocks of every program, basic syntax and output.